So this late part of this afternoon, we're going to explore chops a little bit, and then we'll explore the last family of operators, DATs, data operators, which we haven't really looked at yet. The chops were developed about 10 or 15 years ago. It's used to get data from devices like MIDI at first, and then keyboard, and then connect. We try to support as many devices as we can, sending channel data into TouchDesigner. Also, it's one of the ways to get to and from DMX and Leap Motion and serial devices. It's not the only way to get to and from devices. It's also used to control devices, again controlling OS via OSC and MIDI, and also getting to and from Ableton and other software packages. It's also used to generate time-based animations like keyframing, and it's also used a lot for often when you have devices that are like in a theater and the sensors aren't very accurate, and you have data that's coming in as very noisy. It has kind of spikes in it, and it's kind of drifting. And so chops are really good for smoothing things out and normalizing your numbers and making it kind of usable by the rest of the software. Also, as Ben showed you, it's used for controlling movie playback and controlling effects, image effects, and 3D shapes and tops and stuff like that. And Ben showed a bit of that as well. Another thing it's used for is, especially through a new chop called the timer chop, it's used to kind of control events like a timeline where things happen at certain sequences of time, and then you get to a certain state and wait. So again, it's good for driving cues and a cue list and a show or something like that. And it procedurally generates motion, like LFOs and loops, beats, and stuff like that. It's also used for doing a non-time-based data manipulation. So audio and chops are kind of mixed together because they do kind of the common things. You are using math chops to add things together, and you're splitting channels apart, and you're driving devices. So audio is just a special form of chops. To a large extent, it's used to avoid programming or using C++ to code stuff. So you want to run this file that I gave you. It's at the top here. You can see it's in the workshop. It's under day 1, chop dats. Just run the file called chopsdats.15.to, and it should come up looking something like this. We're going to first look at a few inputs via chops. We're going to first be making this effect. I'll bring it over on the screen here. So basically we want to zap and radiate this character whenever you move your mouse in any direction kind of rapidly. Otherwise, nothing if you move the mouse slowly. So we're going to basically do a little bit of signal filtering. That'll be our first mini project. So as Ben showed you, one way of getting data from the mouse is from the mouse in chop. So if you can just double click on the background and go to chops and get mouse in, M-O mouse in. Also you can get stuff in via the keyboard chop. So let's double click on the background again, get keyboard, K-E, keyboard in. You can also get stuff in, like on my machine I have a Leap Motion set up, so we'll look at that later, but Leap Motion brings data in, and it's, well, it's not connected up exactly, but it gives a gazillion channels. So you don't need to bring that up, but also you get automatically generated channels from clock, so you'll see in a sec. And the clock that you saw on the screen was coming in via this thing, generating channels that you can yank out and express in different forms, including using solar time and moon phase and sun phase and stuff like that. Also, another mechanism is using the beat chop to do things that are beat based, so beat, BE, to generate ramps, multiples of ramps. and so on. So that's used to get periodic stuff that's beat oriented. It can be driven from the outside via MIDI. So let's work on this mouse in data. That's what we're going to use to do this kind of flash on Smiley. First, we want to, as Ben did, you want to normalize the data a little bit. We can take position txty, and if you right-click on the output of it, you can combine the two channels into one using this thing called length. So it's hang on, math chop, and basically it gives you the length from this to the center of the screen, and so that's pre-op. Yes, there it is. Okay, good. Yeah, so when your cursor's at the center of the screen, where it's 0, 0 coming in, mouse in 0, 0, this gives 0, and basically it gives the length from the center to anywhere. We want to look at the data coming in using a time history of it, and we use a trail chop for that. So yeah, middle mouse click on the output to get a branch, and select trail, TR, and look at the mouse data. So you can see how it's kind of even that is steppy. Can't really get good smooth data, so that's kind of a drag. And right now we're looking at a 4-second time history, which is the window length. So it always gives you the most recent 4 seconds of whatever's coming into it. So we can take the math chop and right-click on the output of it and add a filter chop, and set its filter width down to about 0.2 seconds. So actually, yeah, make it about 0.1 seconds. Yeah, filter width of 0.1. Yeah, so when you want to compare stuff together, it's like two chops together. You want to compare what's coming out of here pre-filtered, and then look at what's coming out of here post-filtered. Trail has multiple inputs. It's got 4, so you can compare 4 different chops at the same time. So attach the output of filter to the second input of trail. And so you can see it's a bit more smooth, which is fine. That'll be good enough for what we're doing. And both horizontal and vertical motion produce a signal. So now we want to detect the motion or the changes. So there's a chop that's called slope, which is used to figure out the speed of things, how much things are changing. So if something's not changing, it'll just be 0. If it's rising, it'll be positive. If it's falling, it'll be negative. Middle mouse click a branch off of filter and add in slope. Okay, and why don't we just add that as the third input to trail. Okay, and I'll make it this a little bit higher, like that, so we can see things, I guess, more detail with as we add channels. So, okay, just watch it for now. What's going on? If you move the mouse, so nothing's happening. The last channel, which is the slope, is 0, so it means not moving. Move your mouse to the right, it goes up. Move your mouse to the left, it goes down. So that's kind of a good indicator of is something moving or not. So used for motion detection in the most simplest sense. Then we need to trigger things. So we want to be able to produce an on-off signal based on motion or not. So there's a gazillion ways of doing that. The one I chose here is to use a logic chop. So middle mouse click on the output of slope and select logic. And logic's a little bit like the math chop, except it just uses 0 and 1 values. So you can move trail over a bit. and connect logic into the trail. Okay, so what we want to do is when the slope is close to 0, we want to have a 0 signal, and when it's outside 0, we want to have a 1, 0. So in logic, yeah, okay, so off when outside bounds, there's a convert input which says, normally by default it says off when 0 or less. And here we want it to be off when outside bounds. And then we want to use that to trigger a flash. Okay. So middle mouse click on the output of logic and send that to the trigger chop. One to 1,000 logic. Yeah, it's 1 to 1,000.
Not 2,000.
1 and 1,000 are the limits. Yeah. Yeah. So you can see now. Okay, so it's triggering now when it goes moves. Yeah, so the bound. So when it's outside that range, 1 to 1,000, it's triggered. Okay, so that goes to trigger chop, and the trigger is like attack, decay, sustain, release in audio software. So if we just put this on a separate trail up here, let's watch what it does. Yeah, so in this case you have a attack, decay, sustain, release. As it's moving continuously, it stays in a sustain stage, and then when you let go, it goes back down to 0. So we just want to adjust some of the trigger parameters. So we want the attack length to be, let's go to the attack page of trigger, and we want the attack length to be 0, which is like go on immediately. We want the decay length to be about half a second, 0.66, 2/3 of a second. So make the set that to 0.66 on the sustain page. So it'll take 2/3 of a second to fall to go down, and then we want to go down right down to 0. So we'll go set the sustain level down to 0. So yeah, so this is the kind of look we want now. We want it to go up right away, and then stay up there while it's moving, and then take about 2/3 of a second to drop down to 0. That's the signal that we want to use to do the flash to the image. Okay. Let's. Oh yeah, as per what Ben has recommended, put a null chop after that, because we're going to export from trigger out to a crossfade.
Is a branch, or
that would be a branch off of trigger. Yeah, middle mouse click, branch off.
Yeah.
Yeah, good. Okay, so we're going to want to have two colors, two RGB colors, and one will be dark blue, another one will be white. White will be the flash color. So we'll do that in 2 chops. One chop for each color. So there's a bunch of ways to generate colors, but just to specify an RGB, we can use a constant chop. So bring up a constant again and put it down here on its own, and we'll might as well rename the channels to be RGBA. So just call this one R, and then in this field put G. Now we have 2 channels coming out, and B and A. Okay, so we got RGBA of 0. Let's make the alpha. Well, Yeah, let's make the color like 0, 0, and just a little bit in blue, and then alpha of 1. So we don't see it, but we'll see it eventually. Okay. The next thing we'll do is give a color for the flash. So you can pick it and do a copy paste, Control C, Control V to get another constant chop, and make that 1, 1, 1, 1. The red, green, blue of 1, 1, 1. And we'll crossfade between those two colors based on trigger output. So right click on the output of constant and give it a cross. That's all we need for this. And that. So 2 inputs, and if you go to cross and you go 0 to 1, you can see it crossfades from 0 to 1. It's the blue color to the white color. So we're going to do an export next, which is usual way. We'll do it via viewer active. So click on viewer active at the bottom right of null 1, and make sure cross is picked, and then click on TX and drag it over to the cross parameter and export. And now move your mouse around, and yeah, you can see it automatically doing the transition. We should just do the exercise of the second way of doing a crossfade. So put another cross. Actually, yes. When we do this, yeah, put another cross top down.
It just reacts to the velocity now?
Yeah,
okay.
That's right. Okay, put another cross top down below it, and connect the two chops the same way. And instead of that, we'll use the expression method. So again, make sure cross is picked. Go to the channel, drag it over to the parameter. And this time, instead of saying export, just go to the next one, select relative chop reference, and that will make it turn blue instead of the green here. And it's doing the same thing. If you open up the parameter, hit plus, you can look at it and see that TouchDesigner put a expression in there, fetching it from the operator called null1, tx. So both are equivalent. The net result is the same. Exporting happens to be a little faster, but if you need to, as Ben showed you, do something fancy with the expression, then you need to put Python in there. Okay, so now we just want to do a quick flash on Smiley. So let's first of all get this RGB A value into an image. So we're going to make a 1 pixel image. Right click on the output of cross, and instead of picking another chop, go to the top tab and pick chop 2 instead. So this will create another node beside it. So would I put this?
Yeah.
Okay. I see. That's new, isn't it?
Yep.
I didn't approve that, did I? Okay. Anyway, so okay. So what I did there was again, I right-clicked on the output of cross, went to the top tab, top family, and picked chop 2, and put that here. And this automatic link got created, and you can see that if you roll over the dashed line, it's going from cross 1 to the chop 2 one. Its parameter called chop. So it filled in this parameter chop for us, cross 1. And then we had to change the data format to RGBA, so meaning that the 4 channels coming in are translated as RGBA color. It'll only create 1 pixel. And we can prove that to ourselves by middle clicking on the chop 2, and you can see that the size is 1 one row by one column, 1 pixel, and that's it. So let's then do a different thing for the this image, or sorry, the second image that we're going to crossfade between. So double click on the background to get out another top, which will be a movie file in top. And instead of irradiating the banana, let's irradiate Smiley. So go to the picker, the plus sign, and find Smiley in our list. There he is. Okay, so that's going to be a background image. And from there we'll do a composite top. Right click on the output of Chop 2 and give it composite, and attach the second input to composite from here. In the composite top, we can change the operation from multiply to maximum. So it's our cheap effect of irradiation. Mission accomplished.